everyone, hope you're doing well. Here's a video to go along with today's lesson. And so today we took our look at what if statements and loops look like in Python. And these are really important because these are kind of how you get the complex behavior and being able to do interesting things in a programming language. So today we're just going to see how they work on their own. And next week, we are going to start making a guessing game program that will allow us to see how they're used within a particular program. So let's start off with the if statement. So I'm going to start off with making a new variable. I'm going to set it equal to 1. And we're going to make an if statement that's going to check what the value of that variable is and print out something depending on condition. So an if statement always starts off with an if, and after that you need to put in what is the condition that is going to trigger this if statement. So what do we want to look for? In this case, I'm going to say I want to know if x is equal to 1. So this is an important thing about Boolean stuff, or in fact all programming. In pretty much every programming language, a single equal sign indicates assignment. So this is assigning the value of 1 to x. Alright? But here, 2 equal signs is the same as asking, are these equal? So this is asking, is the value of x equal to 1? I then need to put a colon, and you can see that my cursor does not start at the beginning of the next line, but gets indented. And this is really critical to Python. And so how Python works is it uses white space and indenting in order to indicate and show what is inside of what. And so here, because I'm indented, it means that I'm currently inside of my if statement. So whatever code I put in this section here is only going to run if x is equal to 1. So I'm going to print x is equal to 1. There we go. But what if I want to have something that happens if this does not happen? Actually, forget about that. Let's just see how this works. So I'm going to run this program. So run module, and we need to save it. I'm going to call it test, and it prints out x is equal to 1 because x is indeed equal to 1. But if I change that to say 0 and run this again, nothing is going to happen because this is not true. So this if statement won't run. None of the code inside of the if statement will run. And we don't have any other code, which means that nothing else will happen. You can see, whenever you get these 3 little arrows, that indicates that the program has ended. So we ran the program and nothing happened because that if statement did not trigger, because x was not equal to 1. But you can do something like this. You can say else, and then just a colon. And this else will run if this is not true. So if this if statement does not trigger, then all the code inside of my else statement will run. And so here I'm going to say print x is not equal to 1. Just like that. So now if I run this, this is false. X is not equal to 1. So this code will not run. But this else is connected to this if. So key thing here is an else statement must always be paired with an if statement. If statements can be made by themselves. Else statements always need to go with an if statement. And they need to have the same indentation. So we're going to run this. And now it says x is not equal to 1 because that else statement got triggered and all the code inside of that. ran. But what if you want to check more conditions? So say I also want to do another thing. I could say, well, if x is equal to 0, I could do that. But I wanted to show you something else. I'm going to do an elif. I'm going to say elif x equals to 0. And then I'm going to print here x is equal to 0. I'll put 0 there. Sure. And so it's going to run this code. It's going to check this. If this is true, it's going to run this. And if this runs, nothing else in this entire if block, the entire thing is called an if block, nothing else will run. So key thing about an if block is that only one part of it will ever run. You cannot have this run and that run and that run. Not possible. Only one of them can ever run. So here it's not equal to 1 or 0, because if it gets this far, it means this was not true and this is not true. So if I run this thing now, it's only going to run one of them. And it runs the middle one, because that is the first one it found that was true. Let's I want to show you that it only ever runs once, even if more conditions are true. So for example, here I'm going to say 0, and I'm going to say 0 here. So here I'm going to check if x is equal to 0. It is. And then here I'm also going to check if x is equal to 0. And I'm going to say, change it a little bit, x is also equal to 0. So this way we're going to be able to tell which one of these statements run. And it's only going to be this one that runs, because only one statement in an if block ever runs. Even though this is true, it's not going to bother even looking that far. It's going to stop the moment it found one that is true. It's going to run that code, and then it's going to come down here and then run whatever additional code you have after your if block. We don't have anything after an if block, so no code will run. Let's just run this thing, and we can see it says x is equal to 0, which means it ran this line. Even though this is true, it did not run it because it already found something that is true. Okay? So that is an important part. Only one thing in an entire if block ever runs. And it's always going to be the first one that evaluates as true. So I could say, well, what if x is greater than 0? Whatever. So what I want to do next is I want to look at Boolean statements. So we have a nice condition here. We'll keep this back at 1. This needs to be double equal sign, because we want to know if they're equal. And we'll put 1 there just to fix it all back to how it was. And I'm going to make a new variable. I'm going to say y equals to 1. And sometimes you want to check multiple conditions inside of a single if statement. Like maybe you don't want this to run just if x is equal to 0. Maybe you want to run only if x is equal to 0 and y is equal to 1. How do you do that? We can use Boolean logic. And so Boolean is spelled like this, Boolean. It's a really weird looking word. And all it means is sort of the mathematics of true and false statements. So there's only going to be 3 that we ever really make a lot of use of. There are more, but you can get the same thing or the same effect by just using these 3. And I don't think that Python even supports the other ones anyways. So what I can do is I can use an AND statement to combine 2 conditions. I can say, well, if x is equal to 0 and y is equal to 1. Then we'll say x is equal to 0 and y is equal to 1. And how about we set this equal to 0 and we're going to just check if x equals to 0. So, something like that. So it's going to run this thing again. It's going to check this condition, and it's going to run this line of code because both x is equal to 0 and y is equal to 1. You can see right here. And there we go. It only ran that one code as well. Even though this is also true, it only runs the one statement in the entire if block. But what if I set this to, say, 2 now? So now y is 2. Will this still run? No, it's going to run this one. The reason why is because although this is true, this is false. And is only true, an and Boolean statement is only true if both of these are true. So because this is false, the entire thing is false. If we run it, we just get x is equal to 0 now. So Boolean statements, you can see, do have a special color to them. So true is like that, false is like that. They're always uppercase, at least in Python they are. And we can take a look at how these different operations work by saying, okay, what is true and true? Well, true and true is true. True and false is false, because true is, or and is only true if both of them are true. So true and false is false, as well as false, that's not how you do it, capital false. False and false naturally is still false. Our or statement, however, is going to be true. We haven't looked at or yet, so if I put an or in here, let's go back. So an or statement is the other way you can do things. You can say true or true. This is true. And an or statement is true as long as just one of the two is true. So I can say true or false, and it's going to say true, because at least one of the two is true. And so or is always true if one of them is true, where and is only true if both of them are true. But if we do false or false, that is false. So or needs at least one of them to be true. So that is two of the Boolean operators that we're going to use, and an or. The last one is called not, and not only operates on one Boolean thing. So you can say not true. Not surprisingly, not true is false, and not false is true. And so what not does is it just flips it to the opposite value. If it's true, not true is false. And if it's false, not false is true. And those are the three Boolean operators that we have. I said I was going to get you guys a truth table that you guys can refer to. And I found one that was decent. I put it under Python Basics. So right underneath where the cheat sheet for Python is, there is the truth table for Boolean statements. And you can read it like this. So the first column is what is the value of your parameter. So here you're saying A, it starts off as false, therefore not A evaluates as true. If A is true, not A is false. Over here, you can see what the values for and or are. So if A and B are false, A and B is false, and A or B is false. If A is false but B is true, A and B is still false, but A or B is true. Likewise, if A and B are both true down here, then A and B are true, as well as A or B is true. So we can see that the and is only true when both A and B are true, and OR is true in all cases unless if A and B are false. So this could be a useful reference for you when you're doing Boolean logic in order to combine conditions. So typically you check just if something is equal to or not equal to. Sometimes you do less than or greater than. But those are your major kind of conditions that you typically look at. Yeah. So now let's take a look at loops. Oh, that's the assignment. So let's go back to our program. That's if statements in a nutshell and how they basically work. Like I said, next time we're going to start coding a guessing game program, which will allow us to see how these things are used in a real program. And so if you're kind of confused how this stuff works, don't worry about it. It'll start making more sense once you're seeing it being used and applied. So next thing we want to look at is called a while loop. We have two kinds of loops that we use in programming, a while loop and a for loop. A while loop also uses a condition, just like how the if statement does. And what it does is it loops until this condition that you give it is false. So we can say while x is less than 10. Currently, x is 0, so x less than 10 is true, which means that this loop will run. And it will continue to run until this is no longer true. Notice I put a colon, just like how I did with the if statement, as well as just like the if statement, we got indented in to show that we are now inside of the while loop. And so whatever the code we put in here will only run when this while loop is running. And so I'm going to do x plus equals 1. This is going to add 1 to whatever the current value of x is, and is equivalent to this. Not like that, sorry. Like that. So these two lines are identical in terms of what they do, but this is the way that you typically see it. Alright? So I'm just adding 1 to whatever the value of x is. And then let's print what the value of x is, just so we can see how it's changing and what happens. So let's run this thing. And there's our if statement. And these are the values of x. And you can see that it kept on increasing, it kept on looping, because it kept, as long as the value of x was less than 10, it would then go again. But when it got to 10, remember we're printing out the values of x here, 10 is no longer less than 10, so this is then false, and it exited the while loop. It stopped running it, and whatever code we put after would then run. So that is how a while loop works. However, you don't always have to put a condition like that. Quite often you'll see something that looks like this, a while true loop. And on their own, if I write it like this, there is an issue with it. And the issue is that now the condition of the while loop is always true, which means that this while loop will never stop running. Let's see how that looks. This is now an infinite loop. And you can see it's going and going and going, and it's never going to stop, because this true is never equal to false, and so the loop never exits. So how do you actually save your program or stop this? Because if we leave it, it's not going to stop, right? So how you do it is you go to shell, and then down here it says restart shell, control F6, and that will stop your program if it gets stuck in an infinite loop. Okay? However, this is not like bad coding. You see this actually quite a bit. The key is that you put a condition elsewhere that will allow it to exit the loop somehow. And so we're going to show how to do that by I'm going to use an input statement. I'm going to use an if statement, as well as a new command called break. And we'll see how that's going to allow us to exit this loop when we want to. So I'm going to get an input from the user. I'll say input equals, and then input from the user. Do you want to stop the loop? And I need to put some quotation marks in there because that needs to be a string, just like that. So I'm going to ask if they want to exit the loop. And then I'm using an if statement that's going to check what they entered. So I'm going to say if the input, so what did the user enter, if that's equal to yes, then I'm going to break. So this part we kind of seen before. This is a standard input statement, and so we're just going to get input from the user. Now we're using the if statement, and we're checking if that input is equal to yes. And if we do, we're going to break. And what does break do? Well, break exits whatever the innermost loop you're currently in is. We're only inside of one loop. We're inside of this loop right here. And so this break will exit this loop. All right. And so I'm going to put some code outside the loop. You can see I'm not indented anymore, which means I'm outside of my loop. And I'm going to say goodbye. That way we can see that we've in fact exited the loop and the program is now over. All right. So let's try this out and see that this is a valid way to have a while true loop which doesn't actually go forever. So it's doing the first loop and then it stops because it wants to know if I want to exit the loop. I can say no. No does not equal yes, so it did not trigger the if statement, right? And let's just keep on hitting enter, and it keeps on going. You can see that the loop continues and continues and continues. It's still an infinite loop, but if I put in yes, it then triggered that if statement and broke out of the loop, and it printed goodbye. All right, so that is what break does, and that is how you can exit an infinite loop. So these are, well, true loops may seem like a bad idea because they go on forever. You can use them effectively if you make a condition that will allow you to break out using a break command. Okay? So that is what break does. Now, the last thing we need to look at is a for loop. So a for loop, unlike a while loop, does not have a condition. So what a for loop is for is when you know the amount of times that you want to loop through a particular thing. While loops are really good for when you want to continually loop until a condition is met, but you don't know when that condition is going to be met. So you just keep on doing it until it happens to be met. A for loop, on the other hand, it says, okay, I know how many times I want to do this, and so that's when you would use a for loop. So we're going to start off with a for, and every for loop is going to have some sort of counter index that it uses, and we typically use I for this, but it can be named anything else. I is just simply now a variable name, and it's typically how you see. So if you see for I, know it's a variable name. You can call it other stuff, but that's what it's used for. And then we say for I in range, and I put brackets, and inside of these brackets I put in the number of times I want to loop. So I'm going to say I want to loop 10 times. So I'm going to say for I in range 10. And just like with our if statements and our while loop, we need to put a colon to say, okay, this is the end of that line, and everything else that comes after it should be indented to show this inside of our if our for loop. And all we're going to do with this our for loop is we're just going to print what the value of I is, because I is going to take on a different value every time that we loop through this. So let's get rid of that for now, and get rid of this. In fact, we don't really need any of that stuff anymore. We're just going to look at this part right here. So for I in range 10, let's print out I and see what this thing actually does. So it looped 10 times, and then we said goodbye. That was our last line of our code. And these are the values of I that I took on as it was looping. Notice that it starts at 0, and it went up to 1 less than the number we wanted to go to, or the number of times we wanted to loop. So we wanted to loop 10 times, so it's going to go from 0 to 10 minus 1, or 9. This is extremely common in programming languages, because in programming languages, we start counting from 0. When we look at like lists or arrays or anything like that, we always start counting from 0 rather than 1. And this I is often used as an index for referring to a list or an array. So that's why it starts at 0. This is the most common way that we do this. But we could start from a different number. So for I in range 10, typically we only ever do it like this, but there are more things that we can do with this. For example, I can say range 1, comma 10, so I can give it 2 numbers. If I give it 2 numbers, the first number is where it's going to start from, and the last number is where it's going to stop. So stop but not include. So if I run this, it's not going to start at 0, it's going to start at 1. Just like that. And so because of that, it's not going to loop 10 times anymore. Instead, it's only going to loop 9 times, but we now got between 1 and 9 for our values of I. Alright? You can do the same thing, say like 5 to 20. And that would then start from 5 and stop at 19. 1 less than your upper limit. Okay? Or I wouldn't say upper, I'm going to say your stopping point. You're going to see why I'm changing stopping point and upper. You can add an additional number. So a comma there. And just like that, this last number, if you give it 3 numbers, the first number is where do you want to start from. The second number is where do you want to stop. And the third number is what do you want to count by. And so for I in range 5 will start counting at 5. It'll stop when it gets to 20, but it's going to count by 2s rather than 1s. So it's going to go 5, 7, 9, 11, counting by 2s instead. Just like that. Okay? So that is how a for loop works. So one last thing you can do is, what if I say, okay, this is 20, this is now 5, and it's now negative 2. Now I'm being a little bit tricky here, and this is why I said your stopping point rather than your upper limit. Because this is still my starting point, this is still my stopping point, and this negative says I want to count down by 2s. So I can count down instead of up. And so it's going to start from 20, and it's going to count down, so 20, 18, etc., until it gets down to 6. Just like that. Okay? So that is all the different ways that you can make a basic for loop. There are more things you can definitely do with that, but that would be when we look at arrays, which we might get to towards the end of this semester. But yeah, so that is how a for loop works. So we took a look at 3 different things. These are sort of your 3 major control elements for any kind of programming. The first was an if statement, where we made if blocks, like equals 1. And then code goes here. I'm going to put pass. Pass doesn't actually do anything. It's a placeholder for where the program is expecting code, but you don't have any code there yet. So you never actually use pass in a finished program. It's just there if your computer is yelling at you saying that it's expecting code, but you're not ready to put code there yet. So that's a placeholder, okay? It's not actually doing anything. You make an if block, say x equals 2, and then more placeholder, and else pass again. So that is an if block. We use this in order to change how what a computer does depending on a certain condition. These used a lot. And then we have our two types of loops. We have the for loop, which is used for when we know how many times we want to loop through something. And we have the while loop, which will loop as long as the condition is true. Put in some placeholders. And we also learned about the break, right? And a break works with both kinds of loops. It's not just for while loops, it works with for loops as well. And in either case, it will exit out of the innermost loop it's currently in and continue on with the code. So if I run this thing, none of this stuff is going to do anything because these are all placeholders. Actually, I need to put in X there, otherwise I'm going to get an error. If I did not give X a value when I try to do this check, I get an error. Actually, I'll show you that error. So let's get that error. It said name error, name X is not defined. So when I try to check if X is equal to 1, it gets an error because it has no idea what X is. So I need to give X a value before that. And that fixes that issue. This is not going to do anything. It's going to just loop. Actually, let's just print 1. So it'll print 1. If we didn't have this break, it would print 1 forever. But in this case, it's only going to print it once, and then it's going to break. Then it's going to go into this for loop. It's going to print the first value of I, which is 20, and then it's also going to exit. So neither of these while loops will run entirely because of the breaks. The breaks will work on any kind of loop, just like that. So we got the 1 from the while loop, we got the 20 from the for loop, and then our program ended. Okay? So that is all I have for you today. We're going to be using these next time to make a real program. I'm also going to be introducing the next assignment next time, which is another common errors assignment, this time looking at if statements and loops. It is already up on D2L. So if you go down here, oh, I haven't opened it up yet. How about I make it visible right now? So looping and branching, it's now visible. And here's the next assignment. So now that's visible also. So once again, you're going to download the program that I wrote that's filled with errors. You're going to correct those errors and submit the corrected code to the Dropbox. All right, same idea as our basic common programming exercise. Okay. Anyways, that's all I have for you today. Have a good one, and I will see you all on Monday. Enjoy your weekend. Maybe it's not a long weekend.